I'm here with Professor Misha, Professor to mathematics. We love mathematics. I'm just an amateur. I'm fascinated with the subject. Here we got a professional. Misha would like to speak about pi today, about the history of the constant, the irrational number, transcendental number, and also about the relationship between pi to so many other subjects, some of them more mystical. I'll let Misha do the talking and I'll interfere here and there.
Okay, thank you very much, Ted. So pi is absolutely fascinating things. And in fact, from the moment I looked at this number, I saw this number when I was about 10, it fascinated me because I thought, why should it be uh, kind of present in so many different equations? And the more I studied about it, because apart from mathematics, my other passion is history, I just was more and more fascinated by this number. Why? Because from the very beginning of what we know about the civilization, people from the probably Sumerian time, Akkadian time, people were so fascinated by this number. Because whatever they wanted to build, it would involve some circles,
Mhm.
some wheels, and they had to reproduce it again and again, and they were obviously interested in that number. So from that, they tried to approximate the number, and apparently, my kind of research shows that they found these numbers to quite precise. Kind of the precision was very, very high in the ancient Babylonian time, and then for some reason it was lost. So the Greeks had to reproduce it again, recalculate it again, and in fact, some Greek calculations, like even famous Archimedes calculation, was less precise than what we had in ancient world. I mean, very ancient world in the
Oh, interesting.
Sumerian Babylonian
Just
time.
explain a bit the process if you can about Archimedes. He used the polygons, right, from the outside and the inside of the circle, right, to try to get the best estimation that he could with pi. Archimedes was the greatest mathematician of antiquity, I believe.
Yes, Archimedes was one of the greatest mathematicians and physicists of
Yeah,
antiquities
he was not just
over the
mathematician.
third century before Common Era, who lived in Sicily, and he was fascinated by the number pi. And as you said, he was approximating it from polygons
Mhm.
inside the circumference and outside of the circumference. Yes, and the bigger kind of side this polygon had, the closer
The closer he
the
gets.
polygon is to the circumference,
Mhm.
to the wheel,
Mhm.
so to closer the number. So basically, his approximation was 22 over 3, so 22 over
That's
7.
7.
So 3 and 1 over
Very
7.
good approximation. We still use it, right? You said it's the best one under 100. I remember.
Yes, yes, yes. Well, basically, it's interesting thing is that it's the best approximation under 100. 100 obviously was always a very important
Mm.
number already in antiquity, and the polygon what he also calculated it from also very close to 100. If you know, it's 96 side
Mm.
polygon.
Okay.
Again, looking a little bit on the mystical side. Um, 20 well 7 doesn't number 7 doesn't need
Yes,
introduction.
explain this. This is interesting. You spoke about 22. I remember we had a conversation about it, about the number 22.
Yeah, number 22 is the number of letters of the Hebrew alphabet, and the kind of Jewish tradition says that God created the world using these 22 letters, and
Yes.
have very interesting stories about it, how letter Aleph was created and letter Bet. So God really uses that. So kind of it's almost from kind of mystical, from religious point of view, how we believe that the universe is built from the
Hmm.
hundred and something elements of Mendeleev table. So according kind of old Jewish tradition, Asian Jewish tradition, this is 22 elements from which universe has been built. And number 7, of course, doesn't need any
Introduction.
introduction
Very
because
important, very fundamental number. A great prime number as well, by the way.
prime number as well. Well, number
Beautiful number, I think.
beautiful
Mm.
number. We have kind of the rainbow colors and week days of the week. 22 also has very much of the mystical number because in many kind of numerology studies, in not necessarily only Jewish ones, 22 is also playing big role, as well as you mentioned the prime numbers, as the prime number closest or the factor of the 22, number 11, which is also kind of plays a very high role in the kind of more mystical numerology.
By the way, you can expand as much as you want about it. I think that a lot of people don't know about that side if they like mathematics, and people who don't understand mathematics tend to speak about these things without understanding mathematics. So you here can create a relationship between both. I think to merge these two things together because you're interested in both subjects and you got a lot of professional experience, at least with one of them.
Yes, what you mentioned a very interesting fact, and unfortunately, I think it started a few centuries ago.
Exit, Misha.
Yes, happened a few centuries ago.
Yes.
It well, if we go to more ancient times, again, time of Archimedes, time of Pythagoras, time of other kind of mathematicians.
Pythagoras says it's another thing, but like keep
Yeah, both kind of Jewish, Hindu, all kind of historic people, they did not separate the science, uh, physics from metaphysics.
Yeah, that's how it should be. That's natural philosophy. I want science to be called again natural philosophy. I think the moment they call it science, they destroyed it.
Okay, so and exactly what kind of when the same page. So basically, the ancient scientists and medieval scientists, they saw the creation, the world as one. They didn't kind of separate it in science and theology.
Yes.
Didn't say this is the God's realm and this is the Caesar's realm. This is the realm of kind of the mundane or secular studies. So, what unfortunately happened in the Middle Ages, there was a bit of a conflict, both in Christian world and the Muslim world. There was a conflict between theology and science basically were challenging the domination of the religious order. And religious order kind of were fighting it.
So it became this or that. You either in this camp or that camp.
Absolutely, and it became very, very antagonistic, especially towards 18th century with the Enlightenment, with the encyclopedia. You had to be either or, and if you kind of in both camps, you've been a little bit crucified from both sides. So unfortunately, kind of this dichotomy, which was created, I think, completely well, historically, understandably why, but in our terms, we kind of need to pass it. We need to pass from this.
I agree with you.
Because, and again, if we look at it, why in the 18th century the scientists, the more kind of, they felt like this, because there was history of certain persecution, like, for example, Copernicus couldn't
From the church point of
from
view.
the church, and not kind of throwing mud, of course, to the church, but Catholic Church and basically Christian
people
Church,
abused, if you want to look at it like that, they created the concept in the minds of a lot of people today. I see resentment. I don't want to throw the subject to throw it to a different place, but I see a lot of resentment toward God in a way because the people are afraid of organized religion or the concept of it, of what it can do to people or people abusing power. But I absolutely agree with you. And I think, by the way, that the greatest, I don't want to call them scientists, but the greatest thinkers, Newton, Descartes, Pascal, they were very much people who realized both of these things. That's why Newton wrote about, he was very religious man, and Descartes himself was very interested in that, and Pascal became absolutely religious. He left mathematics altogether, right, at the age of 31, something like
yes.
that. I'm, by the way, not saying necessarily he was doing right thing or not, but I'm just mentioning it. That was really part of their life, and I think it contributed a lot to the discoveries of these people in what we call today science or mathematics. Okay, you do. I have to ask you another question. Yes, but please.
Certainly, maybe when interject about this, if people can feel less convinced, even people much more the scientists, the thinkers, as you call them, I like it, uh, much more, much more recent, more the 20th century, people like Albert Einstein and other physicists, all the quantum physicists. And again, our topic was more mathematics, but physics and mathematics are obviously extremely intertwined. There is,
Yeah, in our day and age, definitely since quantum mechanics and also relativity, you know what I think it reminds me. I saw a quote, in the internet, it's such a jungle, it's very difficult to know, but I'm not sure if I haven't verified it, but I think that Nikola Tesla, he said something about Einstein. He said, "Oh, that's a magnificent work of mathematics, but this is not physics, this is metaphysics."
interesting. We need to look at it. And again,
He might be right for the wrong reasons, by the way, in my opinion. Yeah.
again, I recently read about Nikola Tesla that he had himself very religious background. He would rebel with, but it probably wasn't him somehow. So basically, it's a very very interesting topic. But coming back to the ancient time,
Yes.
it was part of the universe, and they were the thinkers. They were bringing some mystical meaning to the
Exactly, to
numbers.
numbers. Pythagoras, especially the cult of Pythagoras, the secret society. Numbers meant a lot, but it's interesting. That's where we can go back to pi. I want to ask you something. I understand that Pythagoras were obsessed with integers. When someone came, who was the guy who came with the square root of 2? He said, no, it's an irrational number. He proved it. And they said, the story says that they threw him into the sea. They killed him for that.
Well, apparently he was swimming and gods punished him. I
Mm.
always kind of look at it a little bit with the pinch of salt because it was probably easier somebody to send a couple of boys, to drown him rather than kind of rely on God's judgment.
But their relationship with pi, that's what I'm asking. That's not something that was mentioned. I read about Pythagoras, but I just wonder if you know what was if they did they have any relationship with pi?
Well, generally speaking, relationship between integer numbers and
Yes.
pi are very profound, and profound probably because at that time people were thinking more in integer numbers.
Hmm.
Practically all, and it will be interesting to see who did not do this, but practically all thinkers who were considering pi, they were looking at it as their kind of as a fraction of two integer
Yeah.
numbers, whether it was 22 over 7
Or
or
maybe by the irrationality of it. That's what I'm talking about. That's what I understand better than when it comes to the square root of 2.
right, whether the ancients had it proven of the irrationality, that we probably need to speak next time because it's
Okay.
a
No,
very
no,
very
it's
interesting
very
subject.
interesting.
Extremely
Yeah.
interesting subject. But Pythagoras really kind of looked at the numbers
Hmm.
from a very mystical point of view, because again, what we're doing again in kind of a modern view on the ancient Greek thinking process or science or whatever we call physics and metaphysics. We are trying to put this kind of this is Pythagoras and this is Plato and this is Socrates, but in fact, how I understand it, it was a little bit more mystical and slow developing
Hmm.
because that time it's not like now, obviously, when anybody who has an idea publishes it and patented. That time the ideas were developing very very slowly. We know it in Jewish tradition how like Mishnah, Gemara, the Talmud was forming. It was over many years, many discussions, and very often the person in whose name it was said already built it on the kind of on the shoulders of the giants. So Archimedes didn't take it from nothing.
No,
He
it
took
is
it very much from, and interestingly enough, actually Archimedes was from Sicily, and Pythagoras were creating things in Sicily.
He was born in Samos, no? Archimedes, I think.
That I don't remember, but he was most of his life. I think he lived in, and he traveled quite a lot. Apparently, I read very recently that
Okay.
he was traveling to Alexandria. He was really kind of covering a lot of ground. For that time, you couldn't,
Wherever he
travel
was,
very easily.
wherever he was born, for me, he was not born on this earth. Sometimes when I read the things that he was writing about, it just sounds like pretty much above human mind. It's still a human mind. I don't want to call it a godly mind, but it was just tremendous, his discoveries.
Well, that's again a very interesting thing, and very kind of thinking about physics and metaphysics. That
Hmm.
how not only about the scientists and thinkers, musicians and
Yes.
other people. Mozart, my one of my favorite composers. How could they get these beautiful tunes? The
Yes.
same things how Archimedes or Plato or
Mhm.
Pythagoras, how could they draw this divine knowledge? That's an interesting thing, how our mind works.
This is, yeah, okay, keep on,
Yes.
please.
So, but many things I would like to talk, because I think, and hopefully we'll make it kind of a series of the talks. Uh, people, people take mathematics
Mhm.
very, very kind of separate,
Rigid. I think it's too rigid the way that people treat it.
very rigid, and very kind of what I want to say, very separate from spirituality,
Hmm.
and very separate from history. And in fact, it's both very spiritual and very historic. And also people say, like psychology, whatever the research are about your left brain, your logical brain, your
Yes,
kind of
exactly. Separated
scientific
like
brain,
that, yeah.
and your right brain, your more mystical, more emotional brain. It is very kind of modern kind of separation,
Yeah.
modern dichotomy. We should, as much as possible, kind of draw them together. Take it kind of the idea of yin and yang in the
I,
Chinese things.
I,
So you should take it together. You're
I
absolutely on
absolutely,
the same
yeah,
page. Yeah,
and
about
we're
these
on the
things.
same page. You remember Paul Dirac, the physicist?
Yeah.
Some people say that he was, I know about his involvement with quantum physics, but some people would say that he's, someone said actually, I forgot who was it, maybe Michael Atiyah. Do you remember Michael Atiyah, the mathematician?
Yes.
He won the Fields Medal. Maybe it was him who said something. He was very good with soundbite, and he said something like he said that the only difference between Dirac and Einstein when it comes to how great they were, both of them as physicists and important, is that Einstein had the haircut, the right haircut, and Paul Dirac didn't have the one. He was not a great talker either. Paul Dirac was very reserved, very timid. But he said an equation will only work when it's beautiful. It shows
Yes.
you the aesthetics, Euler, the Euler identity, the beauty of it. When we should speak about it, maybe if not now, but we should because pi is there.
Yes. Well, if you think about, and again, I'm kind of, I don't know why. Maybe physicists would take an offense, but not being a physicist, being a mathematician, I love physics, and I think physics is kind of, it's like a twin brother, twin sister of
Yeah.
mathematics. And you mentioned Euler, of course, but if you look at the physicists like Einstein
Hmm.
and Newton, their laws mathematically extremely elegant, extremely simple.
Beautiful, beautiful.
My PhD of a lot of people I know are mathematically much more complicated. There is kind of long equations, the full like whatever. But they're the geniuses, they're kind of pathfinders for all of us. These things are very, very, very simple. As I think uh, Einstein said that all theory should be as simple as possible, but not simpler than that, right?
That's absolutely genius. He was also a genius of sound bites. No wonder that he was so popular. You know, you're just leading me to another thing I wanted to tell you. You remind me that a week ago, I think I found one of these debates, maybe from the 80s, with some poor philosophers. They sit there, you know, and they look so and they speak about postmodernism. They're supposed to define what is postmodernism, and they did the best job to make it more complicated than actually postmodernism itself. They used every word that they could find in the most esoteric dictionaries. And I'm not against language. I love language and I love technical language. But in essence, they made it sound much more complicated than relativity, much more complicated than many other things. And the genius of Einstein, as you said, and Newton as well, which for me is probably the greatest modern natural philosophers,
Mhm.
is that they knew how to simplify these concepts and create them so beautiful. What these philosophers did for me, it was just trying to create something, make it much more complicated than it is.
Yes, well, okay. There are some thinkers.
Mhm.
Uh, I can quote you Karl Marx, who once in his letters said something like, "I'm very tired
Mhm.
and busy. That's why I'm writing you a very long letter." So when I'm kind of my brain is clear, when I'm kind of rested,
Yeah.
I will write you kind of in sound bites.
Mm.
So yeah, absolutely. So the complication, the complexity of things, and again, it's not to deny it. Some probably situations it is appropriate.
It requires complex explanation. Yes, that requires as well complex language. That requires complex concepts. But yes, the genius of someone to create something so elegant, so beautiful. Euler identity, E equals mc to the power of two. Beautiful. We grew up. I grew up. I remember looking at this equation without even understanding it. It was beautiful. I could see the beauty in it.
Yeah, it is very beautiful. But with the numbers coming back kind of to integer numbers, What the I believe that Pythagoras was believing into.
Mhm.
What was more much later, like later was formulated by Plato, that everything, every the idea, the apple has an idea of apple behind it,
Mhm.
and then the cow has the idea of cow behind it, right?
Mhm.
Which exists independently of individual cows. And the same thing with numbers. There is kind of the some basic idea of one
Mhm.
and basic idea of two, etc., etc. And a lot of things what we kind of again take for granted uh, in our society, or even like for a few centuries, is not what it was, because we take for granted, of course, our decimal system.
Mhm.
And which is interesting enough, even kind of thought about it this week or last week. Even if we go to the Bible, to the Jewish Bible, which was written so many millennia ago, like 3 millennia ago, right? It's also explained things into decimal. When they talk, for example, in the camp, there were 25,360 people, they would say 25,000, and they would say
Mhm.
360, exactly how we say.
It's amazing. I never take it for granted, by the way. But
Yes.
you're right about it.
And that was apparently like 33 centuries ago. So basically, this, and why is it? It's because we have 10 digits on our
Mhm.
hands, and it's not
10 fingers, you
on
mean?
fingers, yes.
Yes.
So basically, but it was not always that way. Of course, it was important again to say, because a lot of Babylonian
Yeah, 360.
360, we have 60 minutes in an
Yeah, we
hour,
still use
66
it. Yeah,
minutes,
we still use it.
24 hours.
And there are some people who fight for 12 base. They say that this can be easily be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12,
12 months again. So, but what kind of interests me how these numbers come to existence? Because we were given a beautiful universe. And we are certain way, we have certain fingers, we have certain like
Yeah.
certain objective lengths of the year. So my understanding is that people were these numbers kind of map quite nicely
Hmm.
into the approximate number of lunar months in the solar year.
Yes.
And again, a Jewish calendar, as well as I would think many calendars of the ancient world, was kind of lunar solar. So the thinkers of that time, they were trying to marry the 29 and a half days of the lunar months with the 365 and a quarter days of the things. So again, it was very difficult. Again, very big achievement. What we still have in Jewish calendar is that they've done it like 19 years cycle with the seven extra months, etc., etc., which is interesting in its own. But the point which I try to make it here, that from our experience, from our length of our year, we have special number 12,
Hmm.
because of 12 months in a year. And also the moon, the lunar months is divided in the four stages, kind of going from first quarter, second quarter, third quarter, etc., which is 29 and a half divided by four. The closest number is seven. So kind of this 7 days week makes certain sense. So, but there were other bases of the calculation. People who are like French speakers know that, for example, in French, 99 is 99, which means 4 times 20 and 10 and 9. So for non-French speakers, when first time I learned it, I found it's a very complicated way of
Okay.
explaining it. But that's what historically people were calculating on the base of 20, not 10.
Interesting. Yes. But I would like actually to throw you back into pi because not that we went so far away from it. It's all connected and related. Pi, we spoke about it as well, appears in places where it's allegedly not supposed to appear. We remember Euler, the buzzer problem.
Yes.
What happened there? They tried to investigate this infinity sum converging infinite sum, and it's the reciprocal of a squares, right? You take the natural numbers and you put them to a square, and then you try to calculate the sum of it. And Euler came up, the Bernoullis, they were fascinated by this problem. They managed to work out the harmonic, one of the harmonic series, and then they said, okay, now we have to solve this one. And Euler was the man as often as he did, and he came up with pi to the power of 2 divided by 6 equals to the sum of this magnificent series.
And generally speaking, the kind of pi comes again and again. It comes with all these numbers which come from completely different
Mm.
theory, like number E, the
Yeah,
Euler's number,
yeah, but
and they come and they are in the same equation. So
in the identity,
yeah,
no, the identity.
identity. So basically, it is fascinating because when you think about it, and you can't help a little bit looking to the mystical things, that the universe, there is kind of certain beauty, certain blueprint. It's not kind of chaotic or irrational. There is something
Cosmos.
there, cosmos. Like again, quoting Einstein, that God doesn't play dice with the universe. It's not kind of like, but logically, kind of, you would think that the pi would be in this part of mathematics,
Mhm.
and E, like what we learn at school, with pi we learn very early in our school curriculum. E we normally learn much later because from completely different rationale, but they are part of the same identity. So kind of, it's almost like you go. It's like like how Earth, you go, whatever you go east, you come to the same place, you go west. Kind of a bit round, kind of, it's logical, it's beautiful, it's symmetrical. So, and the beauty of these thinkers, as you call them, rather than scientists, that they were able kind of intuitively get that and elegantly present to us as this identity, for example.
Yes, it is. It's a very beautiful identity. I read a bit about the road to that. How Euler actually came up with a solution to this problem. I think that later he actually had to come up with a proof that was a bit more rigorous to that problem. But that's a different conversation altogether. Is there other places that you see pi, which that are not necessary. That is quite. It's interesting to me. Sorry, before we get there, actually, it's interesting to me that I read in the books that once he came up with this solution, it was fantastic. It was sensational in the world of mathematics for the right reason as well. It's almost like surprised mathematicians that he found pi there. How can you explain it? I mean, people like that should not be surprised, but maybe maybe someone who doesn't. Okay, you
Surprised that the
no,
pi was in the same
yes,
identity, for
yes, or
example.
maybe it's just good for the books to write something like that.
No, actually, I would, again, it's very difficult to fully fully feel what people in the, say, 18th century
Yes.
was thinking and feeling. In fact, I would say that it would be very important for us to understand how they were feeling and thinking, because I don't know, you will kind of, by looking how they thought, we would enrich how we're thinking now, because we're so engrossed in how we are doing things now, and maybe last 5 years, last 10 years. When we go to the kind of, as Romans was saying, ab ovo, from the egg, from the very beginning,
Mm.
you have much bigger insights. So it's difficult for me to see how exactly they saw the world that time. But I think, and maybe what you're alluding to, because in the 18th century they were much more believing in God and afterlife, or whatever they were believing, on the kind of creator of the universe, they should be seeing kind of the hand of God, so to say, from the
Mm.
different parts of the mathematics, and they didn't. Uh, Probably, well, how I would see, when you do science, mathematics, physics, chemistry, the whole idea of scientific method is that you kind of take the creator out of the brackets,
Mhm.
and you really explore it as if there is no creator, there is no kind of external force. And it is fascinating when you, I would probably compare, I don't know, maybe it is kind of too much of a comparison, but how for the first time, humans circumnavigated of the Earth, So they went with the Magellan expedition, 15 whatever, 15, 16. When they went, were going west from Atlantic Ocean to the Pacific, but from Pacific they came to Indian Ocean, then came back to Atlantic and came back to Europe. So in a way, it is a bit counterintuitive because when we go, say, west, we go further, further, further
Mhm.
from home.
Exactly.
But then we go west, 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 and then finally we go back home.
You need to make a conclusion out of it.
Yes. So the same thing in a way in mathematics to an extent. You kind of going from mathematics in mathematics in the realm of mathematics, west, 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 and suddenly you meet yourself
Exactly. You
from
find
this.
yourself,
It's like
yeah.
wow, and that's kind of there's a bigger reality underlying this reality.
It's like
So
an infinite circle that you're just walking. Yeah.
yes. So, and it's very, very easy, unfortunately, for all of us when we are looking at a relatively small, especially in the
Like
last.
ants, exactly. If
Exactly.
you cannot see it, yes.
That's the problem in a way. That's the beauty of our time in a way, because at the moment we are part of a very big scientific educated community. We have thousands and millions of people we can share our ideas with. Probably in the time of Archimedes and even the time of Newton and Euler and
Yeah.
Pascal, it was quite lonely
He
place.
had only, I think someone showed a picture of his library. He had less than 400 books. It's unbelievable. And that's the greatest thinker probably of a natural philosopher of modern times. And today it's so easy to get, you go on the internet, you can find millions of PDFs, scientific papers, books, everything. And he had less than 400.
Yes, and even the number of books, but also if a scientist thinker, as you say, I like that. If the thinker would come to a certain theory, he wouldn't be able to get a second opinion of something.
They used to write letters to each other, but it was more difficult. Yes,
Much more difficult.
Euler was communicating with
Yeah.
Goldbach. They were good friends. Misha, I just wanted to ask you something, but maybe we should leave it for the next time. You spoke about the Euler identity, and I wanted you to expand a bit more about it, but it requires also some conversation about complex numbers. Do you want to leave it for next time?
I think complex numbers and all this kind of discussion and all this controversy
Mhm.
about imaginary
It
partners,
is actually,
etc.,
yeah.
which were kind of used there, uh, requires really quite a separate conversation because again, it invokes a very interesting point. What we need mathematics for? Is it kind of a reflection of the reality? Do we use mathematics as a kind of a bit of a servant of physics and chemistry, etc.,
The Greeks
etc.?
didn't like it applied,
No,
they wanted it
not at
pure,
all. Or mathematics is the goddess, as the Greeks would say,
Exactly, yeah.
which in a way or the queen, as we say probably more now, of the other sciences. And from that point of view, do we need to follow the seen, heard, touched universe, or we can just create these worlds and let the universe kind of I don't know, confirm to us.
I like both, but I think creating is much more interesting. I
I
like when
agree.
mathematics can be the greatest story of your imagination.
Yes, absolutely, and we need both. We need both because of course I don't know what we see around us. Everything what we see around us is made through science. Most things which we see around us is made through science, and the science is impossible without the achievement of the
Mhm.
mathematics. So mathematics is everywhere. The table which we kind of looked at of the technology which we're using at the moment, the stool we sit on, it's all mathematics. So I don't want to denigrate kind of and applied mathematics. Don't want to denigrate it at all for a
Don't
second.
denigrate it, but I don't want it to necessarily to take the front because I think
Yeah.
that people make the mistake to believe if they try to assess level of progress according to technology, while Archimedes didn't have the technology, but he was a great thinker.
Absolutely.
Anyway, I think Misha, we can continue next time with that. It was a
Absolutely.
pleasure talking to you, really.
Pleasure talking to you too,
Thank,
and it's an absolutely fascinating subject.
thank you very much, Professor.
Thank you.
Thank
Thank
you.
you.